Hi, everybody. This is a new episode of the Physics of Bitcoin. It's episode 25, I think, or 26, I don't remember. One of them. We're getting a lot of these episodes now. So a little introduction, like we always do. It's a show where basically we apply a different way of thinking about Bitcoin that comes from our experience as physicists. Both I and Stephen are, we have a PhD in physics, in particular astrophysics. We worked in the field for some time, and then we kind of pivot and went to other fields of science. I worked in neuroscience. Stephen work more in the computational side of things, and this is very important for our understanding of Bitcoin because it gave us an opportunity to see how efficacious is this way of thinking, because it's a different way of thinking about the world. I have later I want actually to show you a slide from Elon Musk, right? He says actually that he wants to approach everything from a physics point of view, because physics, it's more than just a discipline, it's a way of thinking. It allows you to see things from kind of from the ground up, right? You're trying to find fundamental reasons why something happens and why something works. So this is our approach in understanding Bitcoin. We're applying different tools, mathematical tools mostly, but it's mostly a framework to understand the world. And we think that Bitcoin, because of its nature, probably, it's actually, this could also work at a point with other assets, but it works even better with Bitcoin because Stephen always says, I say it's a network, but actually is even more right because he says it's a meta network, right? So it's a network of networks. And network are studied with a physics approach. They are physical entities. They show a lot of properties that are similar to other systems that we see in nature, but they can be biological, but also human-made, like cities and so on. So this is our particular angle, but I think it's a very valuable angle. It's unique. You don't find it anywhere else. So, this is our contribution and our particular approach. Stephen, you can add or modify anything I have said.
Yeah, no, that's a great intro.
Good. All right. And you guys can always interact with us. It's a live show. So, we like if when people ask questions, there is a chat option in our videos. So you can ask questions. So we are going to answer mostly at the end. But feel free to ask a question at any point during the show, and we will get to you at the end where we're answering all your questions. All right, Stephen, you can go ahead and show your agenda, and we can go to the next topic.
This week is a little different. I'm a partner and analyst at OrionX. We're a technology consulting firm that's based in Silicon Valley, and although I'm based in Asia, but we've been together for quite a number of years. Most of us worked together in the high performance computing industry in the past, and at Cray Research, at Sun, at SGI, which was formerly called Silicon Graphics. The founder of OrionX and myself all worked for all three of those companies, and he was my boss at one point, Shaheen Khan. But in any case, I produce a report under the auspices of OrionX twice a year. And I produce it in conjunction with the two big supercomputing conferences. We have one in November that's always in the US, and there's one that for Europe, but it gets an international audience as well. And it's always in Germany. and usually in June, sometimes late May. And that one just completed last week, and we basically put out these reports in conjunction with those two supercomputing conferences. And the reason is that I view Bitcoin as a specialized form of high performance computing or supercomputing. Bitcoin is, in fact, has grown to be the world's largest decentralized supercomputer. Now, it uses special purpose hardware, it uses these ASICs. But once you get outside of the ASICs, there's a lot of commonality, and even more so as Bitcoin mining is becoming more and more industrial. So, you put these things into racks, you rack them up, you have very large machine counts, you've had to go to liquid cooling. It's people talk about hyperscaling in cloud computing. There's a lot of commonality with the high performance computing market, which is where grid computing and cloud computing arose in the first place. So I want to present some slides that basically go into the content of this report. And this is the 14th time that we've done this. Again, we do it twice a year. So we've been doing it since November 2018, and it's been quite interesting to see how it's all evolved. And I'll give some summary of that. And let's go full screen. Okay, here we go. We call this the CryptoSuper 500. The reason is that in the supercomputing industry, we have this top 500 report. And it also comes out twice a year in conjunction with these two high performance computing conferences. And they put together a list of the 500 fastest computers in the world. Those are measured using something called LinPack, which is a library that solves systems of linear equations. It was chosen because it's something that if you grow the system of equations large enough, you can get something close to the peak performance out of the machine. It's basically doing a lot of floating point matrix multiplies. Now, what we do in Bitcoin is different. We're doing bitwise manipulations, but we have the same issue of wanting to scale up to a very large degree. So we've been doing this for 6.5 years. The reports are all publicly available. They're on the OrionX.net website. So people will know, this is for a kind of broader audience. It's less familiar with Bitcoin, perhaps. So some of this is well known to this audience. But this is to show that Bitcoin has, 4 decades of precedence, starting from the 1970s, with very interestingly TCP/IP, right? Because what we have with Bitcoin is money in the internet and of the internet. And it all really started back with TCP/IP and networking. And that's how we got to Bitcoin as a meta network. It shows the 1976 paper by Whitfield Diffie, who was actually one of our colleagues at Sun. I didn't know him well, but we all knew of him. And the other early developments in public key cryptography, elliptic curve cryptography, which Diffie had a hand in as well, and Merkle trees, and then on through, some of the other history that may be more familiar to you, such as David Chaum's work in the 1980s. And, the very last piece of technology from my standpoint that had to be put into place, of course, proof of work is fundamental, but it had to be reusable. And in the first versions, it was more like a postage stamp, one-time use. Hal Finney in 2004 made proof of work reusable. And that's like creating coins that can be used over and over and over. And then, of course, the launch of Bitcoin. So there were many, many people that have contributed to this along the way, as we know. It's not like it just popped out of the vacuum. Our position is that Bitcoin is money 3.0. And so you've gone from single entry accounting, which dates back thousands of years, double entry accounting, of which there was a little bit very early on, but which really came into force at the end of the 13th century and really into the 14th century in Italy with early Italian banking in the 14th century. But Money 3.0 refers to the evolution of money from decentralized form with shells and beads, more centralized things with the Yap Rhinestones, those big wheels that were immobile, but they represented ledgers. I call that 0.x money. And then we went to gold and silver coins, decentralized also, but had state minting. And I call that 1.0. And now, of course, we've been in the epoch for 100 years plus of national fiat currencies 2.0. And it detached itself from the gold underpinnings in a series of stages. Finally in 1971, when Nixon cut the final link. And I call Bitcoin Money 3.0. It's a triple entry ledger, so that's 600-year revolution there. It is decentralized. Digital money stored in and sent across the internet, so it relied on those protocols from the 1970s. Some might say cryptocurrencies are simply digital assets, but I say Bitcoin is much, much more than that. Of all the cryptocurrencies and meme coins that have ever been created, only 76 have market caps of over 1 billion. And very few use proof of work. So the funnel takes us down from millions of meme coins to tens of thousands of cryptocurrencies to only 76 with sort of unicorn level of value, but only 7 of those have that and use proof of work and have a market cap above 2 billion. So it becomes a very narrow funnel that leads to Bitcoin, of course. So I say that money has become information, that Bitcoin is energy that's securely encapsulated as information, as we know through the hashing process. Electrons that go through this sort of alchemy into eternal bits. And a lot of people don't know about the triple entry ledger, breakthrough, but that's also fundamental. The idea that, Geo has a wallet and I have a wallet, and then there's the entry on the blockchain itself. So those are the 3 entries. And of course, the blockchain being replicated thousands upon thousands of times across full nodes.
I'm actually writing an article about the value, where the value of Bitcoin is. And I think we discussed it before. It's a triad, right? There are 3 elements. And this is one of it. It's like a stool with 3 legs, right? And this is one of the fundamental, and is rarely mentioned. People say they go always to, it's a finite cap. What is a finite cap? It's, what does it mean? What is the relevance of it? I think that is a minor thing. The fact that Bitcoin is a perfect ledger. If I had to choose one value proposition, I would say that this is it. And if Satoshi patent this thing, it will be one of the most valuable patents in the world. It's this idea that you have this perfect, decentralized, doesn't need a third party, element to it. It can be just a peer-to-peer. It's really an incredible technological advancement. Like something that you will put in the history books.
Absolutely. That's the foundational thing, is that you have this peer-to-peer, no single point of control, triple entry ledger, replicated, decentralized, global, private, and now recognized by, the Bank of America research analyst as one of the 7 top technologies of the 3rd millennium.
Yeah,
right?
And that was sorry if I interrupted, because I think it's a very interesting topic in general, right? I love ancient history, in particular Egyptian civilization. I took even university level class on the topic. And it's incredible that they manage without money, right? Because money was invented around 400 before Christ, something like that, by the Greeks in
Well,
Lydia, right?
The Lydians had the first
Right.
coins out of electrum, which was a mix of gold and silver.
Yeah, yeah. I mean, it was part of a Greek civilization, even
Right.
indirectly.
Yeah.
And for all that time, you could have civilization without money. That is interesting, right? They had a barter, basically. And, they consider gold as a story of value. But it created a lot of limitations in how they could expand or trade with other countries and so on. So, having the fact that you call it money 3.0, it means that in all these thousands of years of history, we had only three events that can be qualified as the invention of money, right? So it means that it's something that doesn't happen often, right? And so making Bitcoin part of these extraordinary events that happen every few other millennia, hundreds and hundreds of years, right? You say that the invention of a double ledger, right? The double system ledger was one of these events that changed the understanding of money and so on. But money 3.0 is amazing. It's like
it's amazing. It's a millennial invention, and we're living through it. And it happened, right at the beginning of the millennium. So it's really astounding. Yeah.
Crazy.
Okay. So, historically, people in the technology space say, well, is it blockchain or Bitcoin, et cetera? And, it's not either. It's both, because it's an integrated stack. They're both layers. They're interwoven. And, there are three main layers with the Nakamoto consensus algorithm. You've got to enforce security. You do that by having a blockchain and having the difficult proof of work requirement, and then having this triple entry ledger that distributes everything. And then you have to have an incentive mechanism, right? So I think mostly the audience understands all that. And then you want to do other stuff, you do that on second layers or side chains. But it's important not to overload the base chain. Good software design is layered. You look at the communications protocols, the TCP/IP and the HTTP layered on that, and FTP for file transfer and so forth. And that has, multiple layers, up to 7 layers in the stack. And in this chart, just a comparison, of 1.0 and 2.0 and 3.0 and the relative strengths. And we know what the limitations are for fiat. Committees like to increase the supply, whether it be the loan committee in the bank or the central bank committee. And then gold is not very portable and requires weighing and assaying. And so that's what limited gold. Had trouble scaling in terms of rapid movement. Key design elements in the Nakamoto consensus: hash time chain, winner take all lottery, block calendar system, the difficulty adjustment, and the halvings. And the difficulty adjustment is really, really inspired, but absolutely necessary, because you could not keep everything in sync if the block times keep getting shorter, right? So even if you were not having faster and faster machines, not dealing with Moore's law, you'd have more and more people joining the network. So it's double jeopardy, right? As the network grows with the number of machines, and then the machines get faster and faster with Moore's law, you really have to have that difficulty adjustment to keep the blocks roughly equal in time. And the absolutely finite supply allows one to say, this is a scientifically precise standard, 15 digits of precision. Okay, then let's go into the hardware. The mining or minting started out with CPUs. And early on, you had about 5 to 10 mega hashes as the performance. You were drawing 100 watts. Then people discovered that you could use GPUs and run much faster, 1 to 2 orders of magnitude faster in 2011, and draw a little more power. And then FPGAs were tried. That gave a little bit of speed performance, but it was not a huge advantage. The big quantum leap was with the first ASICs, and those were introduced in 2013. And pretty much during the year of 2013, the whole mining flipped over mostly to ASICs. And relative to the CPUs from 3 years prior, they were 1,000 times faster. And so it really was a huge quantum leap. And so when I do my analyses of hash rate growth and difficulty growth, I'm tending more and more to kind of start from 2013 because of the big quantum shift that happened during that year. And then the smaller chart below shows the main ASIC types today. They're in 5 nanometer process, and the foundries are either Taiwan Semiconductor or Samsung. And you see them in the Ant miner and the What's miner and so forth. Each hash trial itself is not a single operation. It's around 1,600 low-level bitwise operations, logical rotation shifts, modular, bitwise adds, and so forth. Very different from what we do in the supercomputing industry and for AI as well, which is floating point calculations, typically 32 and 64 bit, although now for AI, people are able to do calculations with 16-bit floating point precision and even 8-bit, and occasionally even shorter floating point precisions. So now with the current generation ASIC, we're doing 300 to 800 terahashes a second. And as you know, the overall network is, 900 exahashes. And so from that, you can compute that you need millions of machines, right? And relative to the fastest GPUs, the fastest ASICs are hundreds of thousands of times faster than NVIDIA's latest Blackwell GPU for their servers. This is a list of all the top mining rigs very recently. The very fastest are above 500 terahashes a second. And they're also using a lot of power. We're up at 5 kilowatts and 9 kilowatts and even over 10 kilowatts. And so the ones all the ones at the top of this chart have had to go to liquid cooling. And so you see this HYD for hydro next to their name. And you see some pricing information. You see some profitability based on, I generated this with 5-cent electricity, 5 cents per kilowatt hour. For industrial mining, they really need to have their costs below about 5 cents to be competitive. What else? If you just picked, say, the Antminer S21 hydros, it would take 3 million of those to produce all the global hash rate. And of course, you've got a mix of the very latest equipment and older equipment that's out there in the field today. This shows how the difficulty of Bitcoin mining has grown during the ASIC era. So this is a 12-year chart since the middle of 2013. And in fact, you can see in the beginning this kind of rapid rise. And that's during the second part of 2013 when the difficulty parameter was shooting up because ASICs were being introduced very rapidly into the network. But by the end of that year, it had shifted over. And the overall fit is a power law, because this is a log chart of the difficulty log versus the age log 10. And the slope here is 9.5, 9.45. R-squared, very good at 0.94. So it's been rising faster than the 9th power of time, although recently it may have flattened a bit in the past 4 or 5 years. And Bitcoin, I say here that Bitcoin mining is a brutally competitive sport or industry. It just, order of magnitude, if difficulty is rising as the 9.5 power of time and price is rising as the 5.8 or 5.9 power of time, then your gross mining revenue per rig is falling faster than the cube of the age of Bitcoin. So that means, you buy it, you put it into production day one. Well, day two, it's producing a smaller percentage of the overall hash rate, right? So its contribution to the network is falling every day. And then, you've got to, of course, deal with the same electricity cost. Its electricity cost doesn't go down, but its relative contribution, the equipment is depreciating rapidly, losing its edge every day, unless the price is rising faster than difficulty, but that's only a temporary situation. So for example, if you put into service at the beginning of 2025, and if electricity and other operating costs are half of your gross revenue, by mid-2028, the rig would no longer be profitable, even on an operating basis, before considering the depreciation costs and the fact that you're going to have to commit more capital to replace it with a new rig. So you've got a 3.4-year operating life under this particular set of assumptions, and it has very small residual value at the end of that life. And of course, by mid-2028, you're already facing another halving. So there'll be a halving of block rewards towards the end of the life, which will actually put it directly into end of life situation. So for that reason and others, in this very competitive business, most of the mining companies are now adding AI and HPC hosting capabilities so that they can smooth out their revenue profiles, since Bitcoin price is still quite volatile. And they've already built the expertise to scale up. They have low-cost electricity inputs. They do have to have a little bit different equipment because they've got to use GPUs in order to support AI and HPC hosting workloads. But the rest of their infrastructure can be fairly, in common, certainly in terms of their electrical input and their general, power and cooling and the way they rack things up and so forth and operate. As we know, price follows the power law, so you're all very familiar with this. This particular regression shows 5.9 for something called a generalized least square that takes away any autoregression at the weekly scale. Not too much else to say about this. You're familiar with that. We mentioned earlier in our discussion intro, Bitcoin is a meta network. Here are some of the networks. There's the blockchain, there's the miners, there's the Lightning Network, there's the second layer, there's users, developers, merchants, exchanges, full nodes, there's regulatory and legal networks or environments, the service providers, and I'm sure we can think of one or two others, but there's quite a few. And they're all interacting, interplay, and there's their feedback networks, feedback loops between these various networks. Of course, we know it's a major asset. It's worth over 2 trillion. I think even at the 105,000 price, we're just above 2 trillion. And we go back and forth with Amazon, but they're basically 4 companies that have equal or larger market cap than Bitcoin today. We're probably still ahead of Google at 105,000. And we're above silver, and we're above, the world's largest oil producer that's a single company, Saudi Aramco, and above Meta, Facebook, and Tesla, and of course, Berkshire Hathaway, Buffett. Now, our methodology for this study that we do twice a year, this CryptoSuper methodology, is we only consider reusable proof of work mined minted coins because those are the only ones that are using supercomputing power. And we set a cut of 250 million annual value creation. We've had other coins that made the list in the past. We've had as many as 6 cryptocurrencies on the list. They were all proof of work, and they all contributed, at least hundreds of millions, but they've all dropped off except for 2 now. because all the non-mine coins use other Byzantine fault-tolerant algorithms, usually proof of stake or some variant. Of course, they have airdrops for insiders. They have committees, even Ethereum, to decide their monetary policy, right? Ethereum was previously proof of work, but they abandoned it in September 2022, so 3 years ago. The mining protocols and hash rates vary enormously, and Bitcoin is the only one with hundreds of exahashes per second. It's even reached as high as 1,000 exahashes on occasion. And so we've entered the zettascale domain for Bitcoin. Most of them require ASICs to be profitably mined, although the algorithm for Dogecoin is GPU friendly because of the way it treats memory, I think. Mining pools are not miners. They are brokers and aggregators of hash rate, although the companies that own mining pools may do some of their own mining. But they're essentially brokers for modest fees where anybody can point their hash rate to the pool and collect proportional rewards after paying a small fee. And so in the early years of this study, we had to look at the mining pools because we didn't have the VC funded companies, publicly traded companies. So we had less information about what was going on. But after the Chinese shutdown, which was, I think it's 5 years now, where they shut down a lot of their mining capacity, there was a big vacuum left. A lot of production moved to neighboring countries like Russia and Kazakhstan, but a lot moved to North America. And there was a lot of incentive and a lot of startups, money and venture capital funding for publicly traded Bitcoin mining companies. And we now have more than a dozen of those, primarily located in the US, Canada. And they now are responsible for about a quarter of global Bitcoin production. China is estimated to perhaps still have 20%. We don't really have a very good read on that. This is a list of the top publicly traded Bitcoin mining companies. I think there are a dozen on this particular list. You can see what their market caps are. Collectively, there's 21 billion of market cap across these 12 companies. You can see what their Bitcoin holdings are. Mara holds 47,000. When I put this together in late May, and amongst these dozen companies, they hold about 85,000 Bitcoin. They're all aggressive for the most part in expanding the hash rate. And, the larger ones have somewhere between 10 exahashes and 60 exahashes. And most of them are have plans in place, and in fact are already executing on those plans to host HPC and AI workloads. And so there's some discussion in this table of that and some other points. But again, these are mostly headquartered in the US, Canada. There's one company that's in Australia. There's one that's in the UK, but most of the mining itself is in North America. And I've called out some of the other locations, such as Latin America, in the others column. There's around 9 billion in their Bitcoin holdings. And what else? That's about it for this chart. This shows for the top 10 what they mined and minted in April. And so you see a histogram of that with Mara and CleanSpark and Iron and Riot as the top 4 there. You see their monthly hash rates, how many Bitcoin they mined. And so just from that, you can add up and compare to, 450 times 30 to see what percentage of the Bitcoin they were getting. And their hash rate was about 27% of global, and their Bitcoin mined was roughly 23% of all for the month. And these companies mine both for themselves, and that's what's being reported in this table, and they also host for others, who want to buy effectively hash rate capability. 4 of them are consuming over 0.5 gigawatt of power each. And now, of course, we're having more and more holdings with governments and corporations and in the ETFs. So there are 9 governments apparently that are now mining Bitcoin, including El Salvador, Bhutan, UAE, Pakistan. Government holdings now exceed 500,000. The US, I think, is 207,000. China, nearly 200,000. UK and Ukraine have significant holdings. Strategic Bitcoin reserves include the US, the state of New Hampshire. There's activity or laws in process. They may go through in Kentucky. It looks like Texas is going through. I don't know the status of Oklahoma. Pakistan is building up 2 gigawatts of capacity for both AI and for Bitcoin. And then we know about El Salvador and Bhutan. Corporate treasuries were now over 800,000. There are over 200 companies involved. Master is, of course, the biggest one, Strategy, with 580K. And the others collectively, that number's grown larger than 220,000 already. And then private companies, non-publicly traded, over 200,000. And the ETFs and funds, they're over 40 globally, and their holdings are over 1.3 million. And yet, with all of that, over 16 million Bitcoin is in private hands, and that would include amounts that are held at exchanges that are in custodian relationships for private individuals, although in some cases it could be custodians for, private companies or businesses that have not revealed who they are. And of course, only 1.13 million more to be minted. Bitcoin mining is green supercomputing. The energy inputs are over 50% green. And Bitcoin contributes only 1 part in 900 of all of the carbon dioxide equivalent. And it's useful for load shedding, utilities. It's the quickest load on the network that can be shut in. So what we do is we estimate the annual economic value of minted crypto proof of work coins. It's really only Bitcoin and Dogecoin at this point, though only Dogecoin makes the cut as well as Bitcoin. And we look at the daily production. And of course, we know Bitcoin, the money supply inflation is under 0.8%. For Dogecoin, the inflation is a little higher. It's about 3.5% of new coins each year. And the annual production rate for newly minted Bitcoin, including fees, which are less than 2%, is about 18.4 billion per year. So that's the size of the industry, the gross revenue. If you add in Dogecoin, it's another 1 billion. Again, cleaner than average use of global energy, about up to 60% from sustainable sources. I put the question to ChatGPT 4.0, how is Bitcoin greener than other industries? There's the incentive to use renewable energy. Bitcoin miners are very incentivized to minimize their energy costs and to move to the efficient frontier for energy. And that has driven them towards renewables, hydroelectric, wind, solar, geothermal, and now methane capture. Very flexible in their energy usage. They can go directly to the field and capture energy in the field and just, do the Bitcoin mining right there, powered by natural gas or other sources. So they can tap into stranded and off-grid sources, natural gas that hasn't found a pipeline and that would otherwise would be flared. Technological efficiency, there's a lot of competition, and this makes the ASICs more and more energy efficient over time. And many of the mining operations and companies have explicitly committed to carbon neutral goals, and they're increasingly transparent regarding their energy usage. So general trends for mining is that the hash rate has reached new highs of 0.9 zettahashes, as I like to call it, which is 10 to the 21st power, or 900 exahashes, 900 times 10 to the 18. Bitcoin dominance for mining strongly established. Dozen pools broker most of that value. Transaction fees are 1.5%. Very fast mining hardware up to 800 terahashes from a single ASIC based server. Includes liquid cooling, of course. North American dominance with 1/4 of all the production. The bull market since the end of 2022, the electrical input increasingly green. Some geographies will restrict electricity access. So most of the crackdowns on mining, and this is even true apparently of the one in China, have been about kind of rationing the availability of electricity to Bitcoin miners. And we've seen that happen even in local jurisdictions in North America. But the fact that Bitcoin can act as a load balancer makes it actually quite useful for utility operators. And this is a comparison to traditional supercomputing. As I said, we have these lists, these top 500 supercomputer lists that come out twice a year. And I put this table together before the latest list that came out, this month. So this shows the list from November 2024 characteristics, but the number one machine did not change. It's owned by the Department of Energy. It's called El Capitan supercomputer. It has 11 million cores, 11,136 nodes. It uses AMD chips for both CPU and GPU. It consumes over 30 megawatts. It costs $600 million. It's in the Department of Energy lab, and it's used for nuclear security and for science research. And its peak performance is 1.7 exaflop on that algorithm that I talked about before. If you add up all of the machines in this top 500 list, it's not even another order of magnitude in total. It's about 12 exaflops. And of course, the value of all this, since it's producing fundamental science and engineering and AI increasingly, is enormous. Bitcoin, we know how to price the value. It's producing about 18 billion per year, but the network that it's feeding is worth, 100 times that. And so these miners, when they produce new Bitcoin, it may cost them a certain amount. They may, it may cost them 60, 70,000 when you include their capital costs to mint one Bitcoin. And it may have a value today of a little over 100,000, but 2 years from now, it's going to be worth twice as much. So they're minting something of ever increasing value, just as gold has increased in value over time, but much more rapidly because it's growing as a power law relative to gold. I used as a kind of unit of building block, I used these WhatsMiner 63S, which one cabinet has 12 of these ASICs in there, 5 nanometer technology, and they're roughly 300 terahashes. So one cabinet consumes 90 kilowatts. It's liquid cooled. It costs 107,000. It can produce 0.85 Bitcoin per year. So its production value is 89,000 per year. But you amortize that cost over, say, 3 years. And, you scale that up. If that cabinet was used to build out the whole network, it would require 192,000 cabinets. It would consume 17 gigawatts, which is not far off from the actual total consumption of the network. It's got some older, less efficient hardware in there. So right now, the best guess from the Cambridge Center of Alternative Finance is 21 gigawatt. This is 17 gigawatt estimate. And that whole thing would cost 20 billion. But it would it produces 164,000 Bitcoin per year. That's what comes out of the network if your block times are exactly 10 minutes. We do a little better than that. 18 billion per year. So, that's the kind of basic economics, and you can see how that compares to traditional supercomputing in some of these metrics of power and cost and productivity. Okay, I think this is probably closing it out. This is a 6.5-year review of how the list has changed from November 2018, when we produced the first one, until this latest one. The coins making the cut for the first list were Ethereum, Litecoin, Bitcoin Cash, Monero, and of course, Bitcoin itself. And over the whole history of the list, there have only been 9 coins that ever also made it. I can't remember them all. Zcash was one. I think for a little while, Bitcoin SV was on there as well. Now we just have Bitcoin and Dogecoin, so we've seen massive consolidation around Bitcoin. Ethereum used to compete, actively, and at one point it roughly matched in terms of the annual, dollar production, but they just walked away from proof of work foolishly. We've gone from 2,000 cryptocurrencies to over 10,000 active and many more non-active, and millions of meme coins, and most of them are worth nothing or next to nothing. As the Bitcoin market capitalization has increased by a factor of 20, it was of order 100 billion, and now it's over 2 trillion. The price went up 17 times. The annual production has grown by less because of this very difficult, competition that these people have to engage in. So it's gone up by 4.4 times. And the hash rate, though, has gone up, in proportion to the price, 16 times, while the overall cryptocurrency market cap increased 15 times, and the annual production of all cryptos increased by 3.5 times. So that's it. Thank you. This just compares Bitcoin, Dogecoin, what they do, and this shows the 9 coins that were ever on the list.
Okay. Anybody can get this report, or is it free? A free report? Or is a
yes.
paid report?
So there is a Medium article.
Okay.
So search for 14th CryptoSuper 500 report article by me on Medium.
Perfect. And anybody can download it and so on.
That's
Perfect.
yeah. And if people aren't on Medium or something, I've already put on X the friends link, but if anybody needs a friends link, raise a hand on X and I'll resend it.
Now, how close we are in reaching a limit in terms of the Morse law? Because with normal computing, right, a partial way of dealing with Morse law is say, okay, let's have more and more core. Let's focus on making parallel computations, to solve different problems. But you cannot really do that with mining, right? Because the limitation is the efficiency of the calculation, right? How much energy you consume, and you run into real physical limit in terms of damping the heat and stuff like that. How close we are to a limit to that?
A Moore's law limit?
Yeah, an efficiency limit in terms of energy and so on.
We're a ways off. I first touched a computer in 1969, I think it was, or 1970. So I've lived with Moore's law for more than half a century. Mm-hmm. It was my career, and for a long time it was clock rate. I did my thesis on I did my thesis on, 1 megaflop.
Right.
And now we're up to exaflop supercomputers. So Moore's law has not held back the supercomputer industry to date. What did happen, of course, was clock rates maxed out, right?
Right.
And so it forced everybody to go to multi-core, but they found they could not only go to multi-core, they could go to mini-core. So now we've got hundreds of cores on a chip. They've been very innovative about packaging. They've been
But
very
what I'm trying to say, this
Yeah.
doesn't really matter in terms of
speed doesn't matter.
for mining, right? Because they have ASIC anyway. I think you told me one time they are even more efficient than because they are focusing on one single operation and they optimize that. It doesn't really matter, right? In terms of what the normal Moore's law is. What matters is energy, right? The energy efficiency. So this is what I'm asking: how close we are in coming to a limit to that energy efficiency.
We haven't seen any evidence of it. I mean, they've been cranking up the energy efficiency. They've been, cranking down the line size. They're able to follow the broader industry. Mm-hmm. It's the broader industry that's pushed the line size to 5 nanometer and 3 nanometer and 2 nanometer. And then the ASICs, relatively small volume, are able to take advantage of that. And the problem is embarrassingly parallel. I mean, we used to talk about embarrassingly parallel things like genomics, but nothing is more embarrassingly parallel than, the double SHA 256. Mm-hmm. So as long as one can keep adding cores and can manage the power budgets, they're pushing it. They've had to go, more and more to liquid cooling.
I'm again trying with mining. You can actually do parallel ASIC. I thought it was because you have one single operation.
No, but you're doing thousands upon thousands of guesses simultaneously in one ASIC.
Right.
Yeah. You pipeline it, so you actually do parallelism in two directions. You pipeline it through the functional units, and then you horizontally parallelize. These are highly multi-core. They don't reveal how many cores they have, but they have a lot.
Because I talked with some miner and they were worried about the thickness of the wafers being almost at the atomic level at this point, right?
There are concerns about how you get to 2 nanometers and sub that and so forth. Right. And I'm just not all that familiar at this point with the
they were saying that is a real concern because basically we reach kind of how thick a wafer can be. It's like you cannot make it smaller than an atom.
Well, the problem is it gets noisy because the lines are too close to each other, and so you get crosstalk effects, right, between signals that are too close to each other because of quantum tunneling and so on. But that's why they go to more 3D designs, so they have more volume to work with. Obviously, there's other computing modalities, and eventually those will work. Right. There are optical computing modalities that are being looked at, and then there's quantum computing, of course. Although quantum computing is not really going to offer much for hashing for a long time.
Mm-hmm. Talking about quantum computing, by the way, unrelated question. You see all these. Recently, they say that actually they think this was, I think, it was a result from Google. We think actually it's there is a 20 pair improvement in how to resolve some of these crypto problems. Have you read that article, or did you process some of that information? What do you think about that? And does it change? Because we dedicated an entire episode to quantum computing, right? And then I think because of that article, there was a BlackRock statement that saying that is a possible risk for Bitcoin. And then Fred started to get really concerned about this, right? He made a lot of posts saying this it should be a priority, for the developers and so on. What do you think about all that?
Well, it should be a priority because it could be a risk over a 5-year horizon. It may take a little longer. That particular article is not actually a huge breakthrough. That particular individual at Google had talked about 18 or 20 million qubits a few years ago in a paper, and now he was saying, oh, you only need 1 million. But there are others that have talked about 1 million, So when I presented on this, I think here and with Nick Baccia and with others, I kind of used 1 million anyway as a framework. The problem is that you have to have, so far, you have to have a lot of physical qubits in order to get logical qubits. And the Google hardware, the Willow chip, has 80 something, and they were only to get 3 physical qubits maximum. So there's a long, long way to go, but because it's of enormous effect on the entire financial system, then it needs to be concerned. And so that people are concerned, and this is why the National Institute of Standards has run these trials over a period of several years and has now picked 3 or 4 quantum safe technologies. So and of course, this is an attack on the wallets, not on the Bitcoin blockchain itself. That's a different algorithm. This is Shor's algorithm.
Right.
And
these
so
solutions
they have
they require the solution
safe methods that are published. And these are exactly the ones that have gone into a Bitcoin improvement proposal, which is now under discussion.
And these solutions do not require necessarily a fork in the chain, right? We don't need to do an hard fork, maybe just a soft fork.
A soft fork.
Okay. Yeah.
And what's most exposed is the very early coins, because of the public addresses were stored on chain up until 2012. And then there was transition to a way that the public key was only visible when you moved your coins. So those are kind of sitting there more vulnerable. If the quantum computer magically existed tomorrow, that's the coins they would go after, right? The ones that have their public addresses visible, and then the quantum computer could figure out what the private key,
including Satoshi coins.
Including Satoshi coin. That's the world's biggest honeypot.
Yeah.
Okay,
but all this is addressable if
it is addressable with that Bitcoin improvement proposal, and there are others, suggestions. But basically, the quantum safe cryptographic techniques are known and proven, so they just need to be implemented. You just need to have wallets that use those. And so you might have to move your coins to a different wallet address, and that's when your vulnerability would be moving it.
So maybe people should do it ahead of time.
It would make sense to move earlier. Once there's a quantum safe wallet that you have confidence in.
Okay. All right. Let's then I will start my presentation. Okay. So I want to discuss, first of all, let me show you these. I didn't double check that is an original quote. I hope it is. But kind of, I think it's the spirit of, he said things like that in the past. That is what I was mentioning. I tend to approach things from a physics framework, and physics teaches us you to reason from first principle rather than by analogy. Right? So this is actually kind of almost the motto for our show, because this is why we think this approach is a valid one, right? Because we think that approaching Bitcoin from a physics framework allows you to go to the first principle, why Bitcoin behaves in a certain way, right? What are the reasons? If it is a system at certain property, you will expect certain behavior. And our thesis is that Bitcoin is a network, and it shows a lot of these network properties. And this is a lot of what I have done in the last 12 years. It's the core of my work. So I like this sentence a lot. Anyway, so let me, before we go there, what I'm going to show you tonight, it's some updates on work that I have done in the past. But just to give you a context, I have hundreds of slides. Let me show you some of the relevant slides. So there is a lot of evidence that Bitcoin is a network, right? And one of the topics that is fundamental in understanding why Bitcoin is a network is because it's not just the indirect evidence, let's call it like this, of price versus time, that is a power law, and power law show properties. It's one of the indirect signs that you're dealing with a network. Okay, not always, but in particular complex systems like Bitcoin, you can make a case that is a network because, in fact, I like the idea of a meta network because you have machines, we have humans. It's a social network, and then once you understand in that way, you have this framework. So that is my point. What I'm doing a bunch of new interviews recently, and basically instead of reintroducing the entire topic from scratch, what the power law is, and trying to insist that it is not a model. The power law is not a model. It's a framework. In fact, the framework is Bitcoin is a network, and what does it mean? What are the consequences, and so on. So one of the things that is very interesting to me, because it's kind of the root cause, right, is one of the causal links of why we have this behavior in time, is understanding how adoption works, right? So we have only indirect measures of youth adoption, right? One of the direct measures of that we get directly from the chain are the addresses. And one could argue, it's not a perfect proxy because some people create a lot of addresses, other people don't. But to me, it doesn't matter, because if somebody creates a lot of addresses, he acts like an agent that does a lot of things on the chain, and that should result in some kind of expression of this activity in the price. So it doesn't matter, right? User here or addresses can be interchange, or it's more like activity in the network. And so if you study that, if you study addresses as a function of time, you get that it grows basically as a power law. And it is not like many people insist. I don't know why they continue to insist, but probably because they are not aware of the work that I have done, they ignore it completely. They refuse. I don't know, maybe because I think a lot of people, like I saw, for example, presentation from Fidelity, right? They insist about this S curve. S-curve of adoption. I think because we want to make a marketable story, and the story that makes sense to them, because it's a simple story to tell, is that a lot of technologies follow this S-curve. And I want to explain it one more time. I think we did it in the past, but it's such an important topic that needs to be discussed. And by the way, so plan B, that still a lot of people follow, even if it doesn't provide the correct information about these kind of things. And he was showing, it was a technical post on how this S-curve looks like in a log linear chart, in the linear chart. But, with the underlying intention that this meant something to Bitcoin, because Bitcoin, evidently, according to him, follow this S-curve. And this is something that basically everybody else, I don't know anybody else beside me and Stephen saying, no, it doesn't apply to Bitcoin. The data doesn't show, because show me which data you're taking. Like some people, and most of the time they use addresses. There is no other. Now, some people can, I think some organization, CoinGlass, etc., they are trying to get also information from the exchanges. It's not very reliable, right? Coinbase accounts and things like that. You can add all these things, but they will also be indirect measures of adoption. Mostly, that is useful to go from addresses to actually people. Now, I don't know if you ever, I never done really some work on that, or to go from addresses to people, something that will be, have you ever done that, Stephen? Like, for example, do you have in mind a number of users that, number of Bitcoiners in the world? It's something that we can work on, but did you ever done a study on that? Because I always use addresses directly.
No, I mean, people talk about 2 to 3 addresses per user kind of thing, right?
Yeah.
Yeah,
it's going to be a multiple. It's going to be a multiple. Probably there is some distribution, but it's going to be a multiple. For a physicist, multiples don't matter, right? It's just some proportionality constant, right? That is what matters.
But the small users are only going to have one wallet.
Exactly, right? So the majority are going to have one wallet. But let me spend 1 minute to explain one more time. I think we did it before. I did it in interview, what people mean for S-curve, right? So first of all, it's based on this idea that when people adopt a new technology, the distribution of adoption will be a bell curve. In the really technical term for this in math and physics is called the Gaussian, right? So it's a symmetric curve. You can see the left and right side are similar, right? This is similar to what you get with heights, for example, right? There will be a certain number of people on the left, or IQ, or whatever, other parameters, that people are familiar with. You will have people on the left, people on the right, or the distribution. Distribution means you take everybody, right? When you create what are called beans, we call them beans. So imagine you have a box where you put, inside this box, you put how many people go from one value to another value, right? You can have how many boxes you have, let's say 100. Here we see only few, right? But you could have 100 or 1,000. It depends how many data you have. And then you put all these samples in that box and you calculate how many they are. You can do it also as a percentage, right? Like they do it here. You can say, okay, between here and here, you're going to have 2.5% of the total, right? Between here, you're going to have 13.5. Between here, 34. Notice these numbers go higher and higher, and then they started to go down, right? Because you have less and less. So this blue curve represents a smooth, right? Because if you do this in real life, right, with real data, it will not look smooth. It will look like an histogram, right, with like little rectangles. But as you get more and more boxes, it starts to look smooth, and it approaches this curve. You can actually write an equation for this curve. So it's symmetric. What we notice is symmetric. What is really important, it has a peak, and then it starts to go down. Because the idea will be, okay, there are very, very few people that adopted, let's say, Bitcoin in the beginning, several years ago, and then more people started to get in, and then basically, this will be the early majority, but at a certain point we reach kind of like the majority, right? At least 50% of people, because here we have 50 and 50, right? At least 50% of the people have adopted the technology, and then and that will create some kind of acceleration in this curve, because what this yellow curve represents, what is the relationship between the yellow, that is a real S curve, right? What is the relationship between the S curve and the blue curve? It's what is called the integral. Basically, is the sum. If I sum everybody, I count, right? Because if I sum the entire distribution, I will get 100. So I sum all the percentages as I go through these stages. And when I have here, you see it's 50%. When I continue to add, but the distribution will go down because there will be less and less people in these categories. That mean, once everybody, like a majority of people adopted, that is the definition of majority, adopted the technology, that will be 50%, and then there will be less and less and less. There are fewer and fewer people that don't know that technology, or they don't use that technology. Right now, for example, refrigerators, right? Almost everybody, in particular in the first world countries, has a refrigerator, right? So you will go towards this. And you can see as you go towards, everybody basically starts to saturate, right? Because you're reaching the 100%. Notice there is a critical time between when this process started to when you reach the majority. There is a critical event, right? And during that time, here is a little bit smoother as a curve, but depends how narrow this distribution is. This S can be really steep when you reach this majority point, right? And most of the time, this is what we show when we talk about Bitcoin, because the narrative that I think some of these people that describe these things, like analysts, influencers, some of these institutions, is that we are early. First of all, that we are trying to make a story. We are still early, but then one day, that day will be soon, sometime. There will be this critical event where everybody starts to adopt it, and it will look like a sudden event. This where you're going to get these God candles, omega candles, etc. Right? It's a little story, but if we really did adopt Bitcoin in this way, maybe it will even make sense. But it doesn't. It doesn't, because if you use addresses, we are lucky, right? That we, first of all, it would be horrible if we actually knew the number of users exactly that we need, that you will have to sign your name somewhere about Bitcoin, right? And be counted. So it's good that you have some level of anonymity, but at the same time, we do have a rough idea of the usage of a network with these addresses. It's really the appropriate proxy, because even if it is not user directly, it's a measure of activity. I think it's actually even better, because it says, okay, this person is creating a lot of addresses, maybe because it has a big stash, is trying to divide it. It's going to act like a big wheel, right? So that is the idea. And if you look at how addresses look like, they look like this. They look like a straight line in a log-log graph. How this graph will look like in a log-log graph, it will look like it's exponential, and we know what exponentials look in a log-log graph. It look like they're going up, right? So even early on, you will not see straight line. You will see a curve. It tends to go up. I never plotted the entire S curve in a log-log plot. I would probably have to do that at a certain point. But in a log linear graph, this S curve, this is a linear graph. This is how the S curve looks like if I take a linear Y and linear X. But in a log linear, it will look like straight line because it's exponential, and then it starts to taper. This is how it look like. That is basically what Plan B was showing. But it doesn't, right? It doesn't, because we know that something that looks like a straight line in a log-log graph is not going to look in a log linear chart. Is going to look like this. It's going to look like a rainbow chart, right? It's not going to look like a straight line in a log linear chart. So no, because sometimes when I say, oh, it's a power law, some people say, well, but maybe it's early on, and it looks like a power law early on. No, if it was an S curve, you will see it immediately because it will look like exponential. So it will start to bend upwards. It will not look like this. So what is the consequence of being a power law? It's actually pretty cool because that means there is not this characteristic time. There is not a characteristic time. There is not a special time. Bitcoin is doing what it has done all the time. So we are not waiting for this magical time where everybody is going to adopt and there will be this explosion in adoption and so on. Simply Bitcoin continues in an organic fashion to grow in this way. And this is, by the way, is the typical way of growth for the expansion, the diffusion of viruses, right? You can think that Bitcoin is like a virus of a mind, a good virus of a mind. And many other networks, like social networks, for example, these are is what I was showing you before. Let's go to slide 245, where it is. So I started to dig in. So the first thing I discovered, okay, viruses spread in this way. In fact, with this slope of 3, that is really interesting. There is something particular in this value of 3, something that actually I'd like to investigate myself. Why is 3? What that 3 comes from? AIDS, for example, spreading that way with the power law of 3. So here I have a graph where I compare. In this case, I'm showing you how this graph, the power law, looks like in a log linear chart. So if it was an S-curve, it looked like a straight line. It would not look curved like this. And notice, so this is, and you did some work on this, right, Stephen? Like right now we are deviating from being a perfect power law for the internet. So I'm comparing, but most of his history, and you probably agree with me, the internet was actually a power law. That is, I almost never seen anybody mentioning that. It does look like a power law. It's bent. It's not a straight line. It's not exponential. And Bitcoin looks very similar in terms of its adoption. In fact, actually goes faster than the internet. The internet, if you make this model considering just a power law, it's like the slope is 2.6 and Bitcoin is 2.88. It's a beautiful, interesting result, right? It is never mentioned, and I don't understand why, it's really interesting and relevant. And then, there are, and this is how it looks like if you do it in a log plot. They look like straight line, they look parallel. That means they are similar slope. It's really beautiful. It's very interesting. And the consequence, like I say, I made a post about that, is there is no a critical time where we don't need to wait for that. Just let Bitcoin be what it is. And because also this implies, because we see this power law of 6 in time, that the price reacts also in a non-linear fashion relative to the others, is fat, or basically close to the square, because it turns out that you have to multiply the exponents, right, to get. So it's a price is proportional to addresses square, but the addresses also grow with the cube, so 3 times 2, right? So it means we to go by a factor of 100 in price, that is when Bitcoin will be $10 million, we need only 10 times more users. So if we have like, I don't know what, maybe 50 million users in the world, does it seem a reasonable number to you?
Yeah, it might be 80, but it's in that range between 50 and 100.
Right. Yeah. We need only a billion people, right? A billion people to at most to get to $10 million. And that is just a fraction of all human beings on earth. We don't need to orange peel everybody. So that is, this is why I tell you, once you understand Bitcoin using this framework of networks and network theory and properties, you understand so many things that you will not be able to understand if you didn't have this framework. This is why it's not a model. It's really a way of understanding Bitcoin in a completely different way.
So I have a comment. You make orange pilling a billion people sound easy. It's because it's difficult to orange pill a billion people that you follow a power law.
Exactly.
And that you don't get exponential runaway and you don't get God candles. It's
But
not that easy to orange pill people.
no,
It can only be done with adjacent nodes.
yep.
No, nobody gets orange pilled by me. They get orange pilled by somebody they know directly, right?
Yeah.
Yeah.
And so that is one of the reasons, but it's also, it's, and understand it not as a bug, but it's actually a feature, because this allows the system to grow. First of all, you create a people that will stay in the systems. These are not casual users, right? Because once you are an orange pill, your understanding of the world changes. You're holding on the asset, you appreciate it, you studied it, right? And this is what we want. We want this kind of users. We don't want casual users. And it's, it takes time. It will take 20 years to go there. And that allows for the infrastructure to grow, the mining infrastructure, the institution infrastructure, the legal framework infrastructure, all these things, right? So it's the favorite way for growth of nature. Nature prefers this power law growth. There is no, it's not by chance, right? I think I show you in the past. I have it here somewhere. There is this beautiful article that found out that thorns, horns, teeth, shells, they all follow power law growth. And because for some reason in evolution, that was selected as the best way to grow structures using in an optimal way the resources. And so, and it's amazing that Bitcoin found this way. It means that Bitcoin is an intelligent system, right? There is intelligence in how Bitcoin works. That is the best argument against any kind of, oh, Bitcoin is a pyramid scheme, it's going to crash to zero. I don't know why people don't adopt this, because it should be like one of many important stories to tell about Bitcoin. Maybe people don't understand it. I don't know what is the psychological hold up in that, right? Because it's not the easiest story to tell, because it requires some learning, about power laws and so on. But it's the most beautiful story about Bitcoin, and it's true. It's not made up. It's based on reality. And anyway, I found many different articles like this one where it shows that for social networks, these S curves, right? This is why I even use this title. It's even in the title. It says sigmoids, and it's another way to call this curve. It said, we don't see evidence in social networks for these S curves, both the nodes and the links. So the nodes will be the people, and the links, all the different connection between them, follow power laws, both of them. And then this one, I told you, there is for example, this network MDB. So this is an information network, a digital network, right? On basically, these are reviews of movies, right? I think everybody's familiar with these. Like, you can find reviews of different movies. This is a network I didn't know, but existed for a long time, for hundreds of years, for 200 years. So yeah, this one actually was created in 1900s, right? And then there is this other one, Microsoft Academic Graph. They take data all the way from 1800s, so it's a long time. It has a lot of information for hundreds of years. Both of them follow power law. Again, both the nodes and the connections. And so I try to, so in this graph, for example, here is from that paper about the sigmoids. We look at different social networks, and we show that the nodes, the links, and the relationship between them, this will be the equivalent between price and addresses, right? So it's called also the densification. So this is the last chart. It's the relationship between the nodes and the nodes on the x-axis and the link on the y-axis. And you see they are all straight line. This is a log-log graph. These are log linear charts with typical shape that we see when we plot Bitcoin in a log linear chart. These are all power laws, And I try to reproduce these charts. Now, we don't have, and maybe, I don't know if there is a way to calculate links from the blockchain, but you can say I don't know if it is tautology, but I don't think so. You can say, well, the price, it's kind of an indirect measure, like addresses is an indirect measure for nodes. Price is an indirect measure of links, because according to Metcalfe law, the value of a network should be proportional to the number of links. So that is the idea. So if you treat price as v links or something proportional to the links, then you can reproduce these two graphs. Basically one is blue and one is red. Red is the nodes, blue is the links, and you get exactly the same type of graph. You see, exactly the same type of graph for Bitcoin. So it's like one more evidence for the growth of a network, both in nodes and links as power laws. So this is very, very, very cool, very interesting. And what I did all these graphs are a little bit old. I think I did it kind of like 1 year ago. And I did an update of this graph up to a few days ago. It's basically, it didn't change much. The only thing that it's a little peculiar and trying to understand is that flattening here of the latest data. We start to see some flattening in the number of addresses. I'm not too worried, because you can see here we see an acceleration, probably due to a bubble. There was a bubble there, and there was an acceleration, and then there was a correction. So this could be a time where there is some kind of correction, and then we go up. We don't know, right? We need more data. Or another interpretation is that maybe now because of the ETFs, there is also a lot of not on-chain activity that needs to be counted. I need to think about that, how to integrate it. Maybe, Stephen, you can give some feedback about that. One could maybe then add the activity outside the chain. In the end, I think even that activity needs to settle on the chain. But it's possible there is a lot of addresses get kind of clustered in one big address when you buy these ETFs. It's something that I need to explore and understand better. Do you have any feedback on this? Why there is this flattening?
Yeah, well, I mean, I looked at that in terms of the wealth distribution, right?
Yeah.
And I tried to guesstimate how much for the ETFs, how many users does that represent? The same for the corporate, how many shareholders does that represent?
Yeah.
If a country does a strategic reserve, it's their entire citizenry.
Yeah.
So it does shift things in terms of the wealth distribution, which is still very unequal. It's very top heavy. But I think we're seeing that going on here. I think we're seeing that people are going to increasingly are owning in these custodial fashions through ETFs or by owning shares in strategy, or if you're in Japan, there's no ETF, so people buy Metaplanet, right? And that I think is part of the reason why we're seeing the flattening.
Yeah,
but it's not easy to quantify it all.
Yeah, it's not easy, but in theory it could be done. So that is maybe the next level of going deep in the rabbit hole here and making some kind of a model that accounts for that, right? It's something that needs more work. But overall, in the entire history up to now, you see this incredible R squared, 0.97. It looks even better than the price versus time. So it's absolutely not an S curve. It's right now, if you took all the data, including this flattening, you will say it's a power law. No discussion about it. And then the next thing I did, okay, here is the relationship between price and the addresses. Also, this is a power law. It's close to this. The slope is 1.94. That basically is almost a confirmation of Metcalfe law. That Metcalfe law says that the relationship between the value of a network and the number of nodes should be the square, because the square of a node is all possible nodes. If everybody was connected to everybody else, in theory you should get squared. So we come close to that theoretical number. And the interesting thing is when you take the slope for the relationship between price and addresses and you multiply that number with the relationship between addresses and time, you get, the exponent for price versus time. It should be like that, right? It's very interesting, nice to see it actually working out exactly in that way. And then the next thing I did was to look at different cutoffs, right? So I look at, let me see, I have the cutoff, so this is the cutoff for 1 to 10 BTC. So these are bigger wallets. And see, fat one also looks like a power law. And again, yes, overall it does, right? You see the same type of flattening here, kind of flatten up a little bit earlier, probably because it's more difficult to get 1 to 10 wallet. It was easier in the beginning to have one Bitcoin in your wallet. Now it's becoming more difficult, right? I think at least is one interpretation of that. Do you have any other thing to say about this? The fact that actually it looks like this flattening started early on relatively to all the addresses. Do you have any feedback on that, Stephen?
I think it's the difficulty, as you say.
Yeah. And notice the R square is still extremely good. Again, if you wanted to make an argument that overall of the entire history of Bitcoin, we did follow power law. And notice how the slope, right, is smaller. That is simply because there are less addresses with that balance, so it takes longer, right? It's not going to be as fast. The growth is not going to be as fast as if you consider all the addresses. And then the relationship between price and addresses, it's stronger. That means, so this is a super Metcalfe law. Instead of being 2, is actually 3.14. Again, the R square is very, very strong. It's simply because, a small change in this huge big wallet creates a big change in price. It is, the interpretation of what a wallet, I don't know if you can call them dolphins or whatever, right? So that was the first graph was everybody. And that is mostly shrimp because, as Stephen showed, we are still dominated by individual, even if institutions are coming in and buying more and more Bitcoin. Most of the coins are still in the hands of, at least they are small wallets. There are more small wallets than big, huge ones. So this it again shows that the change in a little bit of in the total number of large wallets creates a huge big change in price. It's also interesting how you see these convolutions here, because see how you have a little bit of this, but it's starts to become more complex. I think because the large wallet during a peak, they actually sell. So you start to see less wallets during a peak. This is what it means, that during a peak, the price grows, but the addresses decrease because these large addresses actually sell during these peaks. And here you have a even larger number of Bitcoins in the wallet. These are between 10 and 100, so you could call them whales, right? Those small little whales. Now, what you get, it's again even a smaller slope because these are even more difficult. The graph is less and less of a power law, but it's still overall a pretty good power law with an R square of 0.85. Again, there is flattening here. And then when you look at the relationship, you get this very convoluted behavior here that is interesting. It needs to be interpreted, again, probably because it shows that, these large wallets sell during these bubbles, right? So it's something that we need to understand better, how to interpret this. Right now, for example, you see the price is going up, but the addresses are actually decreasing with these large balances. But again, pretty strong power law, less strong than the other ones, 0.85, very big slope. These ones create a big, huge change in the price when you start to add more of these wallets, more of these addresses. Yeah, 11.13, that is big. But again, if you multiply the two exponents, you get a number that is close to the slope of a power law of price versus time. So this is an update. Like I say, I would like at a certain point to come up with something that makes sense, that also includes the offline activity. I don't know how to do that yet, but it's something that we can work on. So this is my report for this episode. Stephen, do you have any comment or any feedback, any questions on this?
No, not at the moment. No.
Okay. All right. Let's look at some questions. So this is one of the first ones. It says, let me take off my graph. So let's see how to do that. Okay. All right. So let's look at the questions. So it says, let's show this. June is almost over and Bitcoin still can break through the seriously. Time to give up on the cycle theory. What do you think?
I don't have a cycle theory.
So my idea is that up to now, Bitcoin didn't, the price action didn't look too different from previous ones, besides a few of things that we commented in the past, like we usually, once we go over the middle trend line, we stay above the trend line, and that didn't happen for these cycles. We spend quite a bit of time below that line. We comment on this all the time. We say, at least me in other shows, for example, I say we still have a chance to go to 200K. That is, if we follow exactly the patterns that we saw in the past. They were very, very regular and precise, both in time and divergence from the power law. We should get 200K by the end of the year. I'm not ready to say that is not going to happen. I think we will know better by, let's say, end of August, for example. So yeah, it's a little bit different from before, I will say. There is some little evidence that is the case. Mostly, we see less volatility now. Is that due to general pattern in Bitcoin? Is it due to the tariffs? Is it due to the war in Israel? Between Israel and Iran? I don't know. So it's not impossible. It's becoming less and less likely that we reach 200K. If we continue to basically move along the power law, because this is what exactly is happening. The power law is not being violated. If anything, is actually we are following it to a dot. When actually in the past, during this time, we deviated quite a bit. So we don't see these huge deviations like before. Do you want to add anything to this, Steve?
Not really. I mean, I think we're just waiting to see. And it's possible, but it's not assured, is my view.
Correct. And the follow-up question, basically, it's in the same line. I don't know what people mean for super cycle. This, again, is one of these things that people throw there. So far, we never had a super cycle because the cycles have been almost like clockwork. We go 1 year up, we reach certain deviations. Even these deviations, if you look at them as deviations from the power law. So the power law, I always say, the power law doesn't say anything about the cycles. If anything, actually says the cycle don't exist, because you go up, you go down, they cancel each other. If you look at a 4-year moving average, that is almost on top of the power law, that says, once you smooth the bubbles, it's almost like they don't exist. The real activity is the power law. Everything now, you can use the power law to characterize and understand these. I really like this bimodal behavior that we identify, right? That there is this turbulent flow. And the turbulent flow up to now has been very, very regular. It happened a certain time, it lasted a certain time, it decayed in a certain time. We had many episodes where actually Stephen did even a better job than what I did in characterizing all this.
I want to disagree with the entire question and premise of the question and the way it's stated.
Yeah.
It's not a slow grind up. It's a rapid power law increase, 41%. What other asset can you get 41% per year with relatively low volatility? So I disagree with that premise. I do agree with something that it suggests but doesn't state, which is the idea that the power law component is becoming more and more dominant relative to the bubbles. That is, that the bubbles are decreasing in power. I've demonstrated that very clearly, that the power in the bubbles is falling almost with the reciprocal of the age of Bitcoin. It is not to say that we have no more booms and busts. There's still going to be human behavior of bubbles and decrease. I'm not convinced that they follow a cycle, but I do think that global liquidity tends to follow a cycle, and I think global liquidity is important. We know that it's well correlated in the long term with Bitcoin, and I think rapid increases in low global liquidity help to kick off bubbles. They don't sustain the bubbles. The bubbles are carried by momentum, what's it called? Crowding, crowding in, and FOMO. And I think that's
herding behavior.
By herding, that's what goes on. So we're going to have booms and busts. They're not going to be as big as before. And this is going to help with the larger adoption, because it becomes more and more clear as the volatility goes down, not in absolute terms, but in relative terms. As the volatility goes down, it becomes a more acceptable asset for a larger pools of capital, whether at the institutional level. So I think the net of all this is good for Bitcoin's adoption and for keeping it on the power law track, because we need more and more capital in order to do that.
Yeah. And I never understood the super cycle theory. I don't know what.
Oh, well, there are all kinds of cycles. People like these chondriates have cycles and so forth. Yeah. I don't know. We don't have a cycle. We have a technology breakthrough that people don't understand. It's everything they don't understand combined with everything they don't understand about computers, without everything they don't understand about game theory, everything they don't understand by an absolutely scientific standard for money that has never existed in the entire history of mankind. People don't understand it. Yeah. And this is why it has a Hurst exponent of 0.9. This is why we have alpha relative to everybody else. Yeah. We have an advantage to the extent that we understand it.
Now, there are macroeconomic cycles, like PMI is one of them, right? It's actually PMI doesn't cause it. It's like a measure of these cycles, right? There are some liquidity cycles and so on. And I think, the major question is how synchronized Bitcoin is with these cycles. And that actually, we can measure it. There is an entire language of synchronization that one can use. I think neither I or Stephen ever done a study like that using this language of synchronization, because you can measure it in many different ways. You can think about like two oscillators that have some kind of that could be an interesting way, right? To think of it. There are a couple oscillation, and then you can calculate the coupling constant, and how strong it is. Maybe it's a function of time or something. It's something that needs to be done. I want to do that study. That is another way of thinking about this in a physics kind of way. But it's a secondary issue, because really the story is a power law, right? And in fact, actually, first of all, Song for Leah is asking this question. I don't know if you can answer this. Limitation in chip design.
I think we'll find a way, but I don't know how far. What happens is that the advances slow down. It becomes harder and harder, so it takes longer and longer. And the cycles, instead of taking 2 years for double in performance, stretch out to 3, that kind of thing.
So
nanometer, we'll get to 1 nanometer, but I don't know how and I don't know when.
Nanometer means 10 to the minus 9, right? 10 to the minus 9. Why this number is so important? Why nanometer versus any other measure? Well, Stephen.
Atomic size.
Yeah, because an atom is 10 to the minus, that is actually the hydrogen atom, 10 to the minus 10 meters. By the way, 10. As a physicist, you have all these numbers in the head.
You line up, a handful of silicon atoms, and you've got one.
But in particular, if you are larger atoms like silicons, right? You just need few of them to get a nanometer, right? That is the atomic scale. So how much you cannot make something smaller than an atom, right? It doesn't make sense unless you come up with some kind of crazy geometry, something that we cannot even imagine right now. But technology is also wins. That is, in fact, actually, the only good exponential is technology evolution, and that is because every time you're arriving to some kind of crisis where you don't have any more space for for that particular technology, you have a breakthrough, right? When we went from vacuum tubes to transistors, for example. So they look like a bunch of J's. There is this J, and there is another J, and it's only sustainable exponential that we know, because all the other exponentials collapse. Anyway. And by the way, this is the typical thing that people say. I know it's kind of funny and it's a meme, but the answer to that is we're not discussing a model. We are discussing a framework. We are repeating that over and over again. The power law is not a model. It's an evidence that Bitcoin is behaving in a certain way. There are causes that, the nature of Bitcoin is that it's a network. We are showing that it's a network, and we are expecting to see network properties. So it's not a model. It's just how Bitcoin is. So we are describing to you what Bitcoin is and what its properties are. So it's not a model. It's much more than a model. It's a framework. So it doesn't apply, because it will not be destroyed, given that Bitcoin is a network. It will continue to behave like a network. Who approved?
I don't see a question. I see a bundle of raw emotion.
Yeah. Who approves a soft fork to BTC?
The community, just as it's happened with as it happened with SegWit and so forth. Basically, people choose. Miners choose. Wallet providers choose. Full nodes, jump on the longest form.
What if a few governments ban Bitcoin?
People have been saying this for a decade. Never happened.
Yeah, all the governments can ban Bitcoin.
3 to 5 governments can ban Bitcoin. There's 197 other governments.
Yeah, actually, every time that a government goes against Bitcoin, it reinforces the need for people for Bitcoin. They realize, okay,
if your government bans gold, are you going to hand your gold over, or you're going to hide it?
Right. And so actually people realize, okay, this is why we needed Bitcoin in the first place. It's actually a demonstration. Why do we need Bitcoin? We make it even stronger. And that is what happened, because Bitcoin has been banned in China. We were very anti-Bitcoin legislation in the US. You cannot even open, if you want to open an account with Bybit or Binance and you are in the US, you cannot, because even if you are making the legislation now a little bit more friendly, it's still, there is too much legislation in comparison with other places, like, maybe Thailand, for example, right? Or Singapore or whatever, that are much more friendly.
Thailand, all of the regulation trends are going in the other way. Thailand just approved capital gains free sales for Bitcoin for the next 5 years.
Right.
China allows people to own Bitcoin still, and it's a repressive government. So
I might suggest you to study Bitcoin better, because that is the last thing that can happen. Governments banning Bitcoin. It was created exactly for that, making it impossible for any government to ban it or do anything. We can ban it, but it doesn't mean anything. It doesn't have any effect at all.
It's a technology, and technologies live on. Technologies endure.
Connor Sao, Power Law says 100 price increase in 20 years and 10 per number of adopters. I don't know if Bitcoin could be bleed over the 20 years. I think this Connor was trying to answer this question. I think we will continue to follow the power law. We will go up. And as Stephen explained, right now it's 42% a year. We're going down a little bit because it's part of a power law idea. The math works like that. There is a decrease of these basically diminishing returns over time, but they are stabilizing. It will take 10, 15, 20 years to reach like 20%, and that will still beat most of the stocks, and we are continuing to grow. Okay, and yes, it is a power law. So power law, the definition of power law is when you have some kind of power relationship between y and x, right? So if you have y proportional to x to some power, and that n, x to the n, can be any number. It can be negative, it can be positive, it can be smaller than 1, it can be, doesn't have to be an integer or whatever. So in the case of Metcalfe law, it's square. So that will qualify Metcalfe. So basically say the value of a network is proportional to the square of the nodes. And that is because you can show quite easily that if you have a network with a lot of nodes, because it's a limit towards a large number of nodes, it's easy proof, actually. I can give you a proof in a second. Imagine you have n nodes, and everybody's connected to everybody else. So I look at me and say, how many possible connections can I have with everybody else? N minus 1, right? Because it's everybody else and minus me, because I cannot, I can't connect with myself, but it means nothing. So it's n number of nodes times n minus 1 possible connections with everybody else. So that will give you n squared minus n, but in the limit of large n square, like if you have 1,000,000, you take 1,000,000 or 10,000,000 to the square, it's going to be much bigger than minus n. So you can approximate with square. This is how the proof goes. Very quick back on the envelope proof that in the case where everybody is connected with everybody else, the number of links is n squared. The reason why that came about, the reason of the Metcalfe law, the reason actually, you can check it out. Look for, do a Google for Metcalfe speech or something like that. He actually has some kind of a lecture. It's the only one where I could find it. I don't know. Have you ever seen this lecture, Stephen?
I have.
Where he talks about his story. He was trying to tell people, because, and let me tell the story. I know that we are running out of time, but very quickly the story. I think we already said it a few times, but the guy invented the Ethernet. He is the inventor of the Ethernet. And he says this story almost in a humoristic fashion, where in the beginning, when he was selling, this was of the 80s, 90s, when he was selling the piece of the electronics that allow you to connect computers, and then eventually these computers to the internet, right? It was literally a piece of electronics that you had to insert inside the computer, and it cost about $1,000 at that time to buy this piece of electronics. And you will go to institutions like university, companies, and people will buy 2 or 3 of them. And even if you had hundreds of computers or dozens of computers at the time, right? And then he realized, look, if I try to tell them, and it was not a scam, it was based on real knowledge, that the value of connecting computers is not the computers themselves, but the possible links. Because imagine, right? We have 10 people. I talk to Steve, Steve and me talk to James, James, me and Steve talk to Elizabeth. This connectivity is what the value of a network is. I say all the time, the beauty of networks is that the whole is bigger than the sum of the parts. That is what a network is. This is why you have networks. There are units, individual units that decide to work together because they're working together gives you much more value than working individually. And that is what Metcalfe laws says, in a sense, right? It says, listen, the connectivity is really where the value of a network is. That is the beauty of it, right? And yes, it's a power law. It's a power law. Anyway, Raccoon, Bitcoin is still growing, highly mature adoptions. I don't know, we can read all these. Not necessarily, however, when Bitcoin is still growing, adoption scales like a power law, and since Metcalfe law is based on adoption, it also grows as a power law, right? So the question is, if you think about using this framework, right? So it's a fact, it's an historical fact that Bitcoin, you cannot argue. Nobody can come and say, you guys are wrong. If you know math, if you know data, it's an historical fact that Bitcoin follow a power law for 8 order of magnitude, because if you include the first transaction ever between USD and BTC, and you go to 100,000 now, it's basically 8 order of magnitude. So Bitcoin has followed a power law for 8 order of magnitude. The question is, will it continue to follow in the future? And how far? I think because we are going only, if we go to 1 million, it's only 1 order of magnitude. I would say, yes, I don't see anything that limits us in going at least 1 order of magnitude, reaching 1 million. There is no really physical limit. It's going to be tough, right? You need exactly what you're seeing right now, institution intervention, etc. But it's quite likely we go to 1 million. Now, what about 10 million? That is 2 order of magnitude. It starts to become more challenging. And this is why I never go beyond 10 million, because I think several things will happen. First of all, Bitcoin will have half of a worth. This is what Saylor also say. By the time we reach 10 million, the market cap of Bitcoin will be equivalent to all the real estate in the world, in the same order of magnitude. So something is going to give at that point, that maybe that event that we call hyper-Bitcoinization, whatever form it takes, is going to happen at that point. The size of Bitcoin will be comparable with GDPs of some of the largest nations. And then is when these nations will really be serious about Bitcoin, right? Because right now they are kind of cosplaying a little bit, right? Or they start to talk, they're starting to think that no real action is taken in terms of nation state level, right? It's more institutional level. At that time, something will happen. And then we will see, right? So we are talking about 20 years from now. So trying to predict something like Bitcoin 20 years ahead, it's already amazing. So, this is where I think, in a humble way, this is where we should stop. I don't like to project beyond that. I don't know if you have the same attitude, Stephen. All that.
I think we just have to keep monitoring it and see how it's holding up. And right now, the power law is locked in very tightly. It has a very small uncertainty as to what the power law index is. Low volatility, very high statistical confirmation. And there's nothing to stop it. You look at this, all these different things like the Hurst exponent. I mean, it's just very, very solid. And when something is so solid, then you expect it to persist for quite some time. It has that sort of lending an anti-fragile nature to it. And we will see a decade from now where we are, but our best estimate has to be based on taking today's power law and projecting it 10 years.
Yeah. I don't know if you want to answer this question. Tonight we are having a lot of questions. It is good, but I don't know if we can go through all of them.
Well, look, that's up to people's personal preference, whether they want to let custodians own all the Bitcoin. They're not going to own all of mine. It's up to each individual what they want to do. And custodians can add value, but you have to make a judgment as to whether they're the right ones for you, whether you trust them, whether they add value, whether they're worth the fees you pay. And as far as the DeFi market, well, that's a whole nother conversation. So I'm not even going to comment on that.
And we can discuss it another time.
Yeah.
Let's see. I'm going to be a little bit more selective because some of these questions are kind of similar. What is the R square for Gaussian adoption model? You mean for like if you think that there is actually an S curve, it's going to be terrible because it's going. It doesn't
curve. It's terrible. Yeah.
Yeah.
I just checked. I wrote an article last year about the internet and the power law nature of the internet growth for 30 years, and I'm trying to think if I've got the R squared here, but it was in the 0.8 to 0.9, 0.85 to 0.9 kind of range.
Mm-hmm.
Let me
but
see.
Even visually,
no, sorry, it was very, very high. It was 0.97, and I've certainly tried to fit the logistic curve model to Bitcoin in the past, and it's terrible. It's a horrible R squared.
I mean, I already showed you. So the visual inspection is not the ultimate way of judging things, right? But there is a reason why we actually have a terminology in physics. We say, okay, do a visual inspection. This is where you always start, from a visual inspection of the data, right? And I already showed you, I can look it up again, but I already showed you the graph where they look curved. So a power S curve, it's an exponential. It's a double exponential. It's an exponential up and an exponential down. So it will look like a straight line, and it doesn't look like a straight line. It looks curved. Both the internet and Bitcoin will look curved. But it's almost an immediate sign. So you're not dealing with an S curve. It's not an S curve. So that model is not good. And the power law instead looks like a straight line. It does look like a straight line. In fact, it looks even better than the price model. The only thing is this flattening, but there is an explanation for that. This offline activity, but we can reconcile it. It's something that we need to do on a certain point. Is global liquidity a power law? No, it is not. If you look at the long-term history, it looks like an exponential because it's mostly inflation.
Well, I don't know which question is being asked here. The relationship between Bitcoin price and global liquidity is a power law.
Over 10 years, right? So if you look at the longer terms,
I did look longer term. So I did back.
Too. We should compare notes, because if my answer to that, if you look at even longer period of time, all the way to the beginning, you can you see a deviations from.
How far did you look back? Because I looked back
2010.
12. I looked back 12 years.
I look at the entire history, right? So starting to 2010, you start to see the deviation. And in fact, you can see if you look at more than 12 years, like 25, 20 years or more for the global liquidity, it's an exponential. So if a Bitcoin is a power law, a real power law, it cannot be. It cannot have a power law relationship.
Well, this is an important point. Liquidity itself is definitely an exponential, right? And it's something like 7% compound annual growth. Is that right?
Yeah.
That's what it is for the M2 money supply for the US. And so Bitcoin is a power law with very high R squared. Global liquidity is exponential with pretty good R squared. So it cannot be the case that when you cross-correlate the two, that you get a high R squared and a power law relationship.
Right.
And when Howell does it, he gets a modest R squared, but he uses a very short history.
10 years. Yeah.
Yeah.
So over 10 years, because let's say like this: almost everything looks like a straight line if you take a relatively short amount of time, right? So it's a good approximation. In this case, it means it's not like a foundational power law. Like the reason Bitcoin is such a good power law is because of these network properties, right? But then, and so the relationship between the price and liquidity is a model. Is a model in the sense it's an approximation. There is not really foundation in the sense there is not really any reason why it should be some scaling behavior between liquidity and
Here's the
Bitcoin.
fundamental difference. Global liquidity is a superset of a bunch of committees. It's not a technology. Bitcoin is a technology grounded in real physics, in real energy, and in real math, real cryptography, coupled together in a special way. So one is a technology, and is it more real and fundamental than the other, which is just a bunch of committees. And so companies, which are run by committees, and are moderate-sized groups of people, they behave like exponentials. Stock prices behave like exponentials. They're not like cities. Cities behave like power laws because they're dynamic things that are multi-networks, meta-networks that have many layers to their networks and a lot of feedback, and are of a large enough scale that they are, fill this ecological niche and grow and so forth. Companies don't have the anti-fragility that cities have. So exponential.
It's a model.
Are not stable.
It's a model in the sense that they give us a good interpretative relationship, right? You can make some assumption, but it doesn't have a depth of the power laws that we find in Bitcoin itself, because these, I will say, these are foundational in the sense that you will expect power law behavior because of the causes underlying Bitcoin mechanism, and how it grows, how it interacts with the world, and so on. It's a different level, different hierarchies. So anyway,
and when I studied the influence of liquidity, the only thing that I could find that was really, had good support behind it was the idea that if the liquidity jumped sufficiently, then you could get a trigger into a bubble phase.
Correct.
And that was the one takeaway that was most interesting.
Because you have to be careful, right? Liquidity goes up, Bitcoin goes up. Oh, they are correlated. Okay. Where is the causation?
Population goes up.
Yeah. So anyway, and then we have this question. You can answer that, Stephen, if you like.
Yeah, sure. I mean, it has become industrialized. Now you have these, little boxes, these BitXs, that's more like playing the lottery. Somebody can have a very inexpensive device and generate hash rate on their own. And, maybe they get lucky and their chances are better than with a lottery. But in terms of regular mining, there are only two options. One is to be a highly efficient industrial operation, or the other is to buy shares in, or buy hosting cycles from a highly efficient industrial operation.
Yeah, it's still decentralized in the sense that you cannot say that it's only a couple of actors, a couple of nations. So it's distributed in the world, there is competition, etc. It's a conundrum, right? I don't know if Satoshi thought about this.
Problem. I don't see it as a problem. I think it's more important that the full nodes be more decentralized.
Yeah.
And so rather than people thinking that they need to mine for themselves, just run a full node.
Yeah, exactly. Everybody should. If you are a true Bitcoiner, you should run a node. Even just symbolically, as that makes you a Bitcoiner. Anyway, maybe we can answer this last question, and then we can wrap it up.
Yeah. Well, the Hurst exponent is a statistical technique that measures how persistent something is and whether there's a reversion to the mean. And in stock prices and S&P 500 and so forth, those are mean reverting. And for the S&P 500, the Hurst exponent is 0.18. And the difference between random and mean reverting and trending is around 0.5. So if you're less than 0.5, you're very mean reverting. And S&P 500 at 0.18 is very mean reverting. Bitcoin, the Hurst exponent is 0.9. And, you know, I've got a whole series of work on this, and we presented this in earlier talks, and you can go back and look. It measures how big the range is relative to the standard deviation. We don't worry about the details right now. But the maximum tends to be 1, and Bitcoin's 0.9. That means it's very extreme. It's you just don't find investable financial assets that look like this. And so what that means is alpha, you know, relative to other things, and that the alpha is persisting. And if you take the whole history, it stayed above 0.9. So that alpha hasn't gone away. You have an advantage of persistence of price. And it's because of the power law. It's the power law
going up.
Doing this.
When we say, you know, number go up, people have all these sentences, all these claims, you know, because they dealt with Bitcoin, we have intuitive. What me and Stephen are doing are showing that many of these claims are true from a mathematical and logical point of view. This is what we are doing. When people make these sentences, you know, okay, numbers go up. Okay, what is your demonstration? Well, things like the Earth coefficient being 0.9. That is a mathematical quantification of numbers go up, you know. So yeah, this is what we are trying to do. Anyway, guys, thank you very much for all the questions. It was very interesting to have all these questions tonight. One thing I want to suggest you, these episodes require a little bit of study, you know, like in the sense that even myself, I listen to them 2 or 3 times because there is so much information, and we number them on purpose. Maybe at a certain point I can put some titles to describe. There is always a description. You can read the description, but take them almost like lessons about Bitcoin, right? So you can go and, for example, if you're worried about quantum computing, I think it was episode number 5 when Stephen gave a beautiful master class on quantum computing and the danger for Bitcoin. I think it's one of the best presentations I've ever heard on this topic. So go and see that, watch that lesson. They are all on, you can find them on YouTube. But, you know, if you go on my YouTube channel, you can find them and go through them because you're going to learn a lot of things about Bitcoin. Anyway, so good night, everybody, or wherever you are, you know, good day or good night. And we will see you next week.
Thanks, everyone, for joining.
Bye.